recording. Okay, so a couple of rules when it comes to multiplying and dividing fractions. We're going to go through them. The first one is if you've got like 3/8 times 4/5, usually you always hear people telling you that when you time two fractions, it just means you time the numerators together and you time the denominators together. The easiest one to know about this is to remember it is to just think about if you got a half of a half. Yeah, so if you got once you get a pizza and you half a half, what do you get normally?
A quarter.
A quarter. To do that, you need to time those two together and time those two together. Probably not the best example because I'm sure a smart student will come and say to me, oh, but Mr. Mim, you can do 2 + 2, and then that would break it. But you know what I mean. So 2 times 2, 1 times 1. There's always smart kids in every class you go to. So 3 times 4 and 8 times 5, which is 12/40, which should be 3/10. Okay, so 12/40 is 3/10. The way I would do it, if this was me, whenever I see 3/4, 8/5, I try to simplify before even timing anything. Because I know this is 3 times 4, 8 times 5, and that becomes a big 3 times 4 divided by 8 times 5. And if you see this, you go, oh, I can simplify 4 and 8. Because this is 4 divided by 4 is 1. 8 divided by 4 is 2. And I've got my 3 times 1, which is 3, 2 times 5, which is 10. So I don't have to think about 8 times 5 and 3 times 4. It's much.
Does that always work?
Yep, it will always work. Whenever you've got factors at the top and factors, it only works if they're all multiplying or all dividing. Then you can use this. This trick would always work because it means you've got less to do in terms of 3 times 4, which is a 12, 8 times 5. So imagine sometimes you get 7 times 6, yeah, and a 6 times 5. Then straight away you can cancel those 2 6. Then you go 7/5. You don't need to say 7 times 6. What is it in my timetable? So to me, this is the easiest way to do it. But here they're showing you step by step how would you do it, because it means when I've got this 5a times 3, because now we're going to look at algebraic fractions, you need to do 3 times 5a, which is your 15a, 6 times a squared, which is 6a squared. But a squared is just a times a. So you can say to yourself, I've got 15a divided by 6a squared. So I can divide both by 3. That's a 5 and a 2. And I can divide the a with the a squared, and you end up with just 5/2a. But if we had started here, let's say we went, oh, I got a 3 and a 6 and an a. You could have just gone here 5a, yeah, times 3. I'm just putting we times. Divided by 6 times a times a, yeah? So you could have said to yourself, oh, I've got a and a cancel each other because it's just a divided by a is just 1. I've got a 3 and a 6. 3 divided by 6 is just a half. 1 and 2. And you've got your answer there. 5 times 1, which is 5, 2 times a over 2a. And you don't have to go through that whole working and forgetting that 15 is in the 3 times table and 6 is in the 3 times table. because 3 and 6 is easier to see than 15 over 6. Do you agree?
Yes.
So this is the way I would recommend people do them when they get fraction. There you go. Remember, you can simplify top and bottom diagonally first to make things easier, which is what we've done here. Now, we've done multiplication of fractions. You've noticed, easy. You time the numerator, you time the denominator. When it comes to dividing the fractions, yeah, again, so if you think about it, if you got a half divided by a half, right? You ask yourself this question. When you divide two numbers, you just said, how many halves can I put into a half? That's what divide mean, right? 8 divided by 4. How many 4s can I fit into 8?
2.
2. Now, how many half can I fit into a half?
1.
1. So a half divided by a half is 1. It's true because any numbers divided by the same numbers is 1. So how do we get 1 when we've got a half divided by a half? If you change that divide by a multiply, yeah,
Mm-hmm.
I need to time a half by 2 to get 1. Do you agree?
Yes.
Yeah.
Because 2 times 1 is 2, 2 times 1 is 2, 2 divided by 2. What we've done is we've changed that divide sign, we've made it a multiply, and remember that fraction? We've flipped it over.
Mm-hmm.
So that's the trick to use whenever you're going to do dividing of fractions. You're going to change the division sign into a multiply sign, and you're going to flip the second fraction, which is here. 5 over 6 will become 6 over 5. So that's the trick that you need to remember. Yeah? And the carefulness here is you will only start simplifying to make things easier after you've changed that divide sign into a multiply.
Right.
Okay? So 4 over 9 becomes 4 over 9. The divide become a multiply. The 5 over 6 become a 6 over 5. And now we can simplify. We've got a 6 and a 9 if we want. So I think in this example, they're going to do a 24 divided by 45. But here you could have just said, oh, I've got a 6 and a 9. So that's a 2 and a 3. Yeah?
Mm-hmm.
Yep.
Prime number, prime number, prime number. Nothing I can do. That becomes a 8 over 15. But here you've got to simplify a 24 divided by 45. And then you say, okay, you can divide that by 3 and by 3. But you see bigger numbers, much harder to just go 2 times 4, 8, 5 times 3, 15.
Yeah, that's so much easier doing it that way.
Yeah. So you will come to a point where you'll find yourself doing this to make your life easier.
Yeah.
I know we can say, oh, it's only in the 3 time table, but again, it's making your brain working harder with bigger numbers than you do with much smaller numbers. And when we got an exam and it's a 3 hour, I don't know, an hour and a half, 2 hours, whatever you're going to be sitting, you'll find out whatever you can save in terms of time and cognitive work will help you to get to the end of an exam with a much better results. Okay. It's just trying to maximize to minimize the amount of energy you need when you do this work. Okay. So 8 over 15, we found how to do it. We need to do the same for the next one when we've got algebra involved. We changed the divide by a time and we flip the second fraction. And that becomes a y over 5x instead of 5x divided by y.
2xy squared.
Yeah. So now 2xy squared, but look, I've got an x and an x. So you could get rid of those x's. Yeah, you can simplify straight away. So you could have done it a stage earlier and just write 2y squared over 15. Again, prime numbers, there's nothing you could do. You can only divide by themselves. Okay.
It's not too painful.
So we've got a couple of examples making them a bit more complicated. So this is timing. We've not, if you see a divide, you will change the divide and flip the second one. When you got time, easy. We time those two and we time those two. That's it. That's why I was telling you that it's much easier. So 3a, because we write usually the number before the letter, but a3 would have been okay to divide by b squared.
Mm-hmm.
Next one, 2m plus 1 times m. At the bottom, I've got 3 times m squared times m plus 1. Or you can just say, oh, I've got m plus 1, bang, gone. Can you see if you simplify here? You don't have to worry about multiplying 2m's plus 2 times, etc. Then you've got m times m. You can say, oh, I can simplify that with that. And you end up with 2 divided by 3m. Yeah?
Yeah.
Yeah, no,
Instead of, can you see the gymnastic here that you've got to do?
Yeah.
And make sure, oh, I need to do 2m squared. Just simplify, boom, boom, simplify, and you end up with 2 over 3m. Yeah?
Yep.
Mm-hmm.
I can see it.
Which is the way they've done it, but at the second stage, whereas I would always argue that it's better to do right from the start so that you get less chance of making those mistakes. So 2 over 3m, which we got straight away there, 2 over 3m. Okay. Remember, yeah, this is the same thing. If you can simplify beforehand, makes it easier. So let's do a couple of divisions as well. I should have called them example 3, example 4, or 2 and 3, 4 and 5. So this time we're going to change the divide, yeah? That becomes a time. The error that, the common mistake is people see 3 and 3 and they start simplifying the 3. So only think about simplifying when they're all times at the top and all time at the bottom. So the first thing you should do is change that into a time, because now you can see that, oh, they're both at the bottom, so I can't simplify those 3's.
Yeah.
And that becomes just 2y over 9.
Yep.
But I've seen so many times people going, oh, 3 and 3 cancel each other. Oh, this is just 2 divided by y, and they just put 2 over y, which is a complete different thing than changing that to a time and flipping that. Yeah?
Yep.
So basically, technically, what we're doing here, I'm going to show you where that flip is coming from, right? So you've got a 2 divided by 3. I just like people to understand what they do, because it sticks into your brain much easier when you know what you're doing, right? Instead of just learning a change the divide by a time and flip it. So if I want to get rid of a 3 divided by y, I need to time by y over 3, because then that becomes 3y at the top, 3y at the bottom, that become a 1. Yeah?
Mm-hmm.
3y divided by 3y is 1. To get a fraction, an equivalent fraction, whatever I do at the bottom, I need to do at the top. So have a look. I've timed by y over 3. I need to time the top by y over 3. And that's where this flipping and changing to a divide is coming from, because that's a 1. Anything divided by 1 is just anything. And that becomes just 2 over 3 times y over 3. So now that you've noticed, you've seen where it's coming from, you've got a better idea. Why do we change and flip? It's coming from here. Because we divide to start with. And in order to get a 1 at the bottom, I need to multiply by the inverse of the fraction, which is flipping the fractions. Okay?
Yeah.
Yep.
I think you will remember because we've done a few and I've told you, you change and you flip. It's the second one that you flip. But if you know where it's coming from, hopefully you'll have a better understanding of what you're doing. Okay.
Yep.
So this second one, same thing. We're going to flip that second one because we've changed the divide by a multiply. And now I've got a 10 and a 5. I can simplify those. So that becomes a 2. Yeah, 10 divided by 5 is 2. You'd be surprised how many people see 10 divided by 5 and put 1/2. I don't know why. It's a common mistake. I've still not figured out how. I've got so many papers coming back from my S1s and S2s that they've got in their head that because they're doing a division, it's got to be a fraction, and they don't see 10/5 being a 2. You see what I mean? They see it as 1/2. And it's hard because you just tell them a fraction is a division. What is 10 divided by 5? And unless I put it on the paper and saying, how many 5s can you put in 10? And they go, oh yeah, that's 2. But why did they see this as being a half?
Something they must learn in primary school, like in terms of portions and how you know,
Yeah.
they do that in the infants, like in terms of like, and how many you have something, and
Yeah.
grouping and stuff like that. Maybe that's just what they maybe use in their head.
Or maybe the fraction, because when I said to them, what is this? And then they go, oh, that is 2. So why do you write 10 divided by 5 like a fraction, not 2? Or it's because of that fraction bar. Don't know why. Anyway, I've got to figure that out myself. So here they've get the 2 out and said, okay, this is going to be 2 times 10, which is a 20, times x plus 2. And at the bottom, they got the 3. So they factorize 2x plus 4 with 2 times x plus 2 and 3 times. Whereas now they've got to simplify 20 divided by 15 because they're both in the 5 time table, and they get the answer as 4/3. So that's your final answer. But we could have got it here by factorizing and factorizing. Yeah. So I would put the brackets there. Okay.
Yeah.
And now comes the beasts. And you go, whoa. This is, how do we do this? This is just about factorizing. You've got to use the method MAM or whatever you call it to factorize, and you'll find out by factorizing you will end up. But the first thing, remember what we said, we need to change that divide as a time. So once you do that, then you can start your factorization and simplify. So I've got 2 numbers. When I time them, I get -2.
It also comes to a 1.
That's going to be 2 and 1. So 2 will be the positive, and 1 will be the negative because I've got a positive. I've got here 7 and 12. So 3 times 4 will give me 7, yeah? So 3, 4. I've got 8 and 6, 4 and 2.
2 and 4, yeah.
So now you can see how you just work your way, and then 3 and 1. And eventually, you can just rewrite that whole thing like this. And now, because I've got that, time this, time this, this, time this, time this, time this, I can start simplifying. X plus 4, x plus 4. Go. X plus 2, x plus 2. Go. X plus 3, x plus 3. Go. Because that's 1, 1, and 1. 1 times 1 times 1 is 1. X minus 1 divided by x plus 1. Yeah?
Yeah.
And that's your final answer. So
It
that
makes
would
life
have
a little
been
simpler.
1, 2, 3, 4, 5, 6, 7, 8 now, but to be honest, I've never seen this given. They would probably say, I'm going to give it as a 1, 2, 3, 4, and then 5.
This is the year they're going to put that exact question in. This is it.
So as long as you've got a method and then you can simplify very quickly, that should be 5 marks.
Yeah.
It's doable.
Yeah.
Yeah.
And they were not that hard, because
No.
what you'll find is you can use some of the, so if you start with x plus 2, x minus 1, there will be some x plus 2 somewhere. Then the next one, x plus 4, x plus 3, oh, there's a 3 there.
Unless you slip up during MAM though, that could be a game changer though.
Yeah, but I think these are easy enough.
Yeah, they're quite easy to figure out.
4 and 2, 3 and 4. So they're not going to make them too complicated.
They even get the same signs. They're all positives. Well, the
Yeah,
majority are
the
positives.
3 here. You're right. They could have made it a bit harder by making one of them negative or something. But no. So it looks daunting to start with, and we end up with just x minus 1 divided by x plus 1. Okay. So now what goes in the box?
12 over 2. 1, 6. 1 over 6.
Yeah. So you could have said to yourself, simplify 2 and 4, 2 times 3, instead of going through the 2 over 12. You could have simplified straight from the start. Yeah. The next one would be 2 times 3, 6 BC. And the next one, 3 times 4, 12 divided by b squared.
B squared.
So the only one you would need to simplify would be the first one.
Yeah.
Okay. So when it comes to divisions, what did we say we do?
Change
the sign and then flip it.
Yeah. So you can just say this is going to be that, and then 12 over 5 for this one. And the 1 over 6, we keep it the way it is. And I've got 12 divided by 6. That is, yeah, that is your 2. And answer 2 over 5. This one, you would flip it, so time and flip. So a times a would be a squared divided by bc. Yeah.
Yep.
This one I would get y at the top. So this is
x, y.
Yeah, so x over y time. So this is the bit where I would rather put proper x's. Y over 4x. So we're going to simplify again. X divided by x, that's a 1. Y divided by y, that's a 1. 1 times 1 is 1. I end up with a quarter. Okay? Easy enough?
Yep.
Now you'll be able to practice. We're going to do a couple, and then I'll let you go.
Sorry, can you go back? It's just so I can write that down.
Yeah, sorry.
Homework.
Exercise 7.
Resume recording. So what we could do, we could probably do a couple here. So you pick, you let me know.
You go, Kirsty. You pick.
Can we try H?
Oh,
Okay.
that's grim.
Start difficult. Finish on an easy one.
Okay. And for an easy one, we'll probably do, yeah, we can do D. Okay. So when I see this, every time I see this, first thing I said to myself is, I've got fraction, and I know any number I can rewrite it as a fraction. Okay, so that's probably the easiest way to do it. It's a bit saying like I've got x plus 5 divided by 1, so that'd be my first fraction. Okay. And I'm timing another fraction. So that means I'm going to have to time the numerators and the denominators. So x plus 5 times x minus 5. Straight away I can see difference of 2 squares, and at the bottom I've got 3 times 1. And that is just x squared minus 25, yeah,
Over 3.
over 3 times 1, which is 3. And there's nothing else I can do. You leave it like that. So even if I had like x squared minus 18, so I've seen people being tempted, oh, I need to divide 18 by 3. No, this is a whole, so you can only simplify when you've got that in bracket against something at the bottom in bracket. Okay, so let's try the next one here. So the next one, what I'm seeing here is I've got x plus 3, yeah, and x squared minus 4. So straight away I can see difference of 2 squares for the x squared minus 4, which is an x plus 3 at the top, times x plus 2 times x minus 2. So that's my top portion, okay? Do you see it, yeah?
Yeah.
So that means whatever is at the bottom, it's going to have some x plus 3s or x plus 2s or x minus 2s when I'm going to use MAM. So let's see the first one. So 2 numbers to get 2 and 1.
2 and 1.
So x plus 2 times x plus 1. Do you agree?
Yes.
Straight away, you see that x plus 2 at the top will cancel each other nicely for me.
It's 3 x plus 1.
And because we're timing 2 fractions, I can just open the bracket for the next section. It's going to be time. I've got 4, 3, and 1. So x plus 3, again, times x plus 1. So it looked daunting to start with, but it wasn't too difficult because now I can start simplifying, yeah? So to simplify, I'm going to say I've got x plus 2, x plus 2, that's a 1. X plus 3, x plus 3, that's 1. And I end up with just x minus 2 at the top. Divided by
X plus 1 times
x plus 1 times x plus 1, which is just x plus 1 square. You don't need to do x squared plus 2x plus 1. You can just say x plus 1 square. That's the simplest form that you can give. Okay?
Yeah.
And again, you'll probably do something similar with the next one, but you've got difference of 2 squares, and they've put negative numbers just to make it a bit more complicated.
Yeah.
But you can see it looked daunting to start with, but once you can see
When you simplify it down, it's a lot easier.
Yeah. And the last exercise I've left is division. So we'll do 1. So you can pick
D.
You can pick 1 if you want.
Do D.
Yeah, in the middle. So let's try D. So this time we've got 2x squared. First thing first is I'm going to change my division into a multiplication because that's easier for me. So 2x y squared divided by 3 time, remember this 6x squared y is the same as 6x squared y divided by 1. This is the bit that you need to really think about. Now I'm going to flip that, yeah, which is a 1 divided by 6x squared y. Okay. So we've changed the division and we made it a multiplication and we flipped the fraction. Now I'm going to simplify here. I've got a 2 and a 6. 2 divided by 6 is just 1/3, because I divide by 2 the top. 6 divided by 2 is 3. Now I've got a y square and a y, so y times y and a y, so these goes, an x and an x square, and my answer is 1y, which is y, divided by 3 times 3 times x, 9x, and that's us.
Right.
So the bit that you needed to remember is this 6x squared y is the same as a fraction of 6x squared y divided by 1. So that's probably the hardest one in that whole group, because you wouldn't be able to do it if you didn't remember that you can change that as a fraction. Whereas the rest are all fractions, so that should come up quite easily.
Yep.
Okay.
Okay.
That's fine.
And let me see. Yeah, so after that, what I've put after that is I always put some past paper questions just to give you an idea, a bit of flavor, what kind of past paper question that sometimes you can see and what you would do and how you can simplify, etc. Just to give you an idea, especially the day you're going to have to revise. It's always good to have some questions already there that you're probably not tempted or. Okay.
Okay.
I think
Thank you.
that should be us. I'm just going to stop.